Hey guys!
Have you ever wondered how things go boom?
How rockets go to outer space? Or how going kaboom is related to rockets?
Well, you've come to the right place. We're going to tell you all you need to know about two specific chemicals used in explosions and rockets, and then compare their chemical properties. My name's Kelly.
I'm Andrew. And I'm Jordan.
So first, let's see how things explode. While there are many different ways that things can explode, like fireworks, cars, or bombs, we're going to focus in on a specific chemical that is commonly used in explosions. This chemical is called trinitrotoluene, or more commonly, TNT.
This compound is often used for military and industrial purposes, meaning you can use it in bombs or for mining to help clear unwanted material. In fact, TNT is so explosive that the scale used to measure how much energy is released from an explosion is called the TNT equivalent. So you're probably thinking, what makes TNT so explosive? Well, let's take a closer look. TNT is made up of 4 different elements including carbon, nitrogen, oxygen, and hydrogen. These elements interact with each other by forming a ring of carbon atoms called toluene, and attached to the ring there are 3 nitro groups. Keep these elements in mind and let's begin to think about how they play a role in TNT's explosion.
At room temperature, TNT is in a solid state, but crank the temperature up to around 80 degrees Celsius, which is relatively low, and your solid will melt. Comparatively, the table salt that you use every day melts at over 800 degrees Celsius. Even when melted though, TNT doesn't just instantaneously detonate. So why is it so explosive?
Let's look at the reaction that takes place when TNT explodes. In order to actually make TNT explode, you need to add lots of energy by impact, friction, spark, shock, or heat. Then, when TNT goes kaboom, it produces nitrogen gas, carbon monoxide, water, and just pure carbon, which is soot. All of these products are very stable compounds, which means that the energy you release is huge. In fact, at 3,400 kilojoules per mole, the amount of energy released from TNT is 10 times more than the amount of energy produced to fuel your mom's minivan. Also, when it explodes, TNT burns or detonates at a rate of almost 7,000 meters per second. So you can burn through 700 football fields in just 1 second. Okay, now let's take a look at how rockets go to outer space.
Since World War II, when there were rocket-powered planes, and even today, a chemical called hydrazine has been used as a rocket fuel. So how does something that looks like water get a rocket ship into space? In contrast to TNT, hydrazine actually has a very simple chemical structure. It's made up of only 2 nitrogen atoms and 4 hydrogen atoms. Remember how we told you that TNT has a low melting point? Well, hydrazine's melting point is exponentially lower at a teeny tiny 2 degrees Celsius.
Now, let's take a look at how hydrazine actually reacts to help fuel rockets. Unlike TNT, hydrazine goes through 3 different reactions. One to produce ammonia, a household cleaner, one to produce nitrogen and hydrogen gas, and one where it uses ammonia to form even more nitrogen and hydrogen gas. These reactions produce a lot of heat and energy, similar to the one with TNT. In the first few milliseconds, these reactions produce heat that is up to 800 degrees Celsius. Finally, one main difference between TNT and hydrazine is that with hydrazine, you don't add energy to make it react. Rather, you use something called a catalyst. A catalyst is simply something that lowers the amount of energy it takes for a reaction to take place. So, by simply exposing hydrazine to a metal called iridium, this rocket fuel begins to get excited and reacts quickly to form lots of heat and energy, propelling your rocket into outer space and beyond.
When looking at the reactions of TNT and hydrazine, nitrogen gas is produced by both compounds. This is the explosive component. Due to a small size of nitrogen atoms, they can get really close and form a triple bond. The formation of this bond releases a ton of energy that can be used in things like missiles and spaceships.
So, now you have some idea of how explosions work, how rockets go to outer space, and how these 2 reactions can be very similar, but different. We hope you enjoy our video and learned a lot.
Until next time,
bye!
Created using Powtoon.